In this video, I'm going to show you how to build this hexagon grid in Godot 3D, just like Civilization and plenty of other hexagon strategy games. I'll also provide all the code in the GitHub repo that you can find in the description below. Let's get started. Okay, so you can see that I've started a blank project and that I've added a main spatial node just to kind of get something there. So it's just a spatial node that I've called main. And the first thing we're going to do is import in our hexagon model. And if you don't have one to use, or if you just want to follow along exactly with the tutorial, I've got one that will be on the GitHub repo linked in the description below that you can download to use and follow along. It's the same model that I'm going to be using. So let me import my hexagon model. I'm going to drag it right in to our project here, and you'll see now there's unit.hex.glb, and then there's going to be the material that comes with it by default. And so what I'm going to do now is actually create another node. I'll hit add child node and add a spatial here. And this is going to be a container for our HexTile. Eventually we'll have a HexGrid that's going to be our entire map. It's going to be our collection of all of our hex tiles. But when I'm referring to an individual hexagon, I'll call it a hexagon tile or a hex tile. And we want to create a custom scene that's going to wrap our hexagon model that we can use for this. So I'm just going to call this hex tile. And like I said, this is just going to be our wrapper scene for our hexagon. I'm going to right click on it and hit save branches scene to make it its own scene. And I'll hit save, just call it hex tile. Now I'll hit the little scene button here to go into our hex tile. And what I'm going to do is actually come down to our file system and drag in our unit hex, our hexagon model here. Just drag it into the scene tree. Come over to our unit hex, hit the transform, just reset it to make sure it's centered. Now this is a unit hex, both in my modeling software and in Godot. I'm not scaling it at all. It is just a default scale of 1. So that's going to be important because we're going to provide a way to make our hexagons bigger or smaller later on. But now that we've got our unit hex here, we are good to go. We've got a wrapper scene that we can instance in our hex grid. So let's actually start making our hex grid. And in order to do that, we'll come back into our main scene. So I'm going to select our main scene, hit Command A or Control A if you're on Windows to create a new spatial node. And similar as before, I'm going to call this hex grid because, like I said, this is going to be our entire map, our entire grid of hex tiles. I'm actually going to delete the hex tile we created before. We don't need it anymore. And then in HexGrid, I'm going to add a script to it. We'll just call that hexgrid.gd, and we'll be good to go. Let me get rid of a lot of the boilerplate here. And what we're going to start off doing is within our ready function, we are going to call a function, which we'll create in just a second, called generateGrid. And let's actually define generate grid now. You'll notice that I've given it the underscore in front of it, which in Godot is kind of the syntax to denote a private method. That is a method we don't really want anything outside of this script to call. So we'll create a function with the same signature, generate grid. And for now, we'll just say pass. We'll come back to that in just a second and start adding code there. But first, let's define a couple constants. First, we need to get a reference to the actual hex tile scene that we just made so we can instance it in our game. We'll say const, all capitals, hex tile here. And the reason I'm doing constant is because this is going to be a constant reference. It's not going to change. And with just, it's a common syntax that whenever you have a constant value, saved as like a field or as a member variable of a script or a class, you want to uppercase it just so that it denotes anywhere else you use it. Hey, this isn't going to change. It's just common syntax that lets any user working on your code to know that this is a constant value. So we'll follow that syntax here, and then we'll say equals, and then we'll preload our hex tile. And we can preload because, again, it's a constant path. We're always going to be using this hex tile. Then I'm going to create a new constant right above it, and I'm going to call this tile size. Now, what this is going to be is it's going to be the scale of your hex tile. Remember how I said that my tile wasn't scaled at all? We're going to be using 1.0, and it's important to make sure it's a float here so that Godot will try and use float math instead of integer math, and it won't truncate things. Now, if you want to scale your hexagon tiles up individually, you want them to be a bigger size, you can use this variable to do it. There are also ways to get this tile size programmatically rather than hard coding it, but just for the ease of doing this tutorial, we'll hard code it as 1 for now. If you're unfamiliar with this := syntax, that's just telling the Godot interpreter what type it is. It's telling Godot to infer the type of this variable from the default value I give it. So since I say 1.0, since I give it a float value by default, the Godot interpreter will see that and be like, oh, okay, this has to be a float variable. I'll make sure that any value that tries to get assigned to it is a float as well. Of course, it's a constant, so we can't assign to it, but just a quick rundown of that syntax. Okay, so now that we've got our constants set up here, we're ready to actually start generating our grid. Actually, that's a bit of a lie. We need one more variable here, and we're going to make this an export variable, and this is going to let us determine from the editor how large our grid is going to be. Again, just for the sake of this tutorial, I want to just do a square grid. So if we define a grid size of 5, it'll be 5 hexagon tiles wide and 5 hexagon tiles tall. It'll just be a square grid. You can modify this on your own later on, but for now, we're just going to do that. So let's define that variable. We'll say export, and we want this to be an integer because we want it to be just a square number. And I'll say between 2 and 20 for now, just to give it a type hint to make sure that we don't have grids that are too small or too big. And I'll say variable grid size, and again, I'm going to set this equal to, we'll just default it to 10 for now. Okay, so now we've got our constants and our grid size variable set up. Let's actually start coding. And the way that we're going to create our generate grid function is by pretending it's just a square. So we're going to do a for loop going through the rows and a for loop going through the columns. We are going to start by doing the columns first. So I'm going to say for x in range. If you're not familiar with range, it's a function that returns an array of the numbers leading up to the number you define. So I'm going to pass in grid size here. So if our grid size is 10, this range function is going to return an array of the values 0 through 9. So it's going to loop 10 times. So we'll do for x in range grid size, and then again, we'll do for y in range grid size. 10 columns and 10 rows per column. Okay, and we'll come back and add some more code to this later, but now that we've got our general for loop set up, we can start adding the actual instancing of our tiles. So we won't worry about the actual position of our tiles for now. We'll start by just instancing them. So first, we can actually instance our tiles. Since we have our HexTile pack scene saved into a variable, we can say variable tile, we'll just call it that. And this will be HexTile.instance. Because it's a pack scene, we can just call instance on it. And now we will have an instance tile. Now all we have to do is add it as a child. And note that this script is attached to our HexGrid, so it's going to be added as a child to our grid and not to our main scene. And now we're going to add a new tile for every tile that needs to be there as part of our grid. The problem is that they're all going to get instance on top of each other right now. So now we need to do a little bit of code that will help us to move them apart. First, in order to do that, let's create a new variable, and this is going to be a variable that keeps track of the current coordinates, or the coordinates of our current tile. It's going to keep track of where our current tile should be instanced in the game world. So in order to keep track of the coordinates for our current tile, let's make a new variable, and we'll call this variable tile coordinates, just so it's very clear what it's doing. And we're actually going to make this a vector2 and default it to vector2.0. So it'll be a vector2 of 0, 0 in the x and y. And you'll notice that we are doing everything with x and y coordinates in a vector2 right now. But we're going to be actually creating our grid in 3D. And so the way that's going to work is our y coordinate is actually, when it comes to 3D space, going to be our z coordinate. Because in 3D, we don't want to move a hexagon tile up or down in the y-axis like this. We instead just want to make sure that we are translating our y-axis of our tile coordinates into the z-axis of our 3D world when we're actually moving our tile around. Okay, so let's start just with the simplest thing in the inner loop, going from row to row. So we're not going to go column to column yet. We'll just build things within the same column. So we'll just pretend x is always 0. It's always our first column. And we are going to build our first column by going row to row here. So what we need to do is imagine we instance our first hexagon, right? Well, we need to move the next hexagon down the full height of our first hexagon. And it's important to notice too, if you look at the hexagon tiles we're using, that the faces, the two flat faces, are top and bottom. The top and bottom aren't edges or vertices. They're not the long diagonal here. They're two faces. And So what we can do then is just make sure that we're moving down the full height of our hexagon tile, and that'll get us to our next one. So what we're going to do is say tile.translate, because we want to translate our tile down, and we'll say vector3. So we're going to create a new vector3. And for the x coordinate of our vector3, we want, as you'd expect, tile coordinates.x, because we want it to be in the x coordinate of the tile coordinates of the coordinate it should be at. And remember, we said we're not going to do anything in the y plane for our vector3. So this is actually just going to be 0 for our y value. And for z, this is where we're going to translate tile coordinates.y into the z axis of our 3D world. So we're going to translate our tile to a certain amount in the x direction and a certain amount in the z direction according to whatever our y coordinate is for our tile. Now, you could skip the whole vector2 to vector3 thing and just do all of this in vector3. I just figured I'd do it for this tutorial in the hopes that it'd be less confusing to first think about our hex grid in a 2D space and then translate it to 3D. But if it's a bit more confusing, don't even worry about it. Just do it in 3D in your own game. Okay, so now we're moving our tiles correctly, but the problem is that we're never actually changing tile coordinates. So whenever we move a tile down to the place it needs to be, we need to set the tile coordinates for the next tile to be one tile down. So in order to do that, all we have to type is just tile coordinates.y and plus equals tile size. This is where our tile size variable is going to come in handy, because like we said before, we're just moving our hex tile a whole unit down, a whole tile down. And so now each hex tile that we build is just going to be one tile down. And we can actually run it now and see that even though we're only going to have one column, we can actually see that it's building correctly. In order to do that, we'll have to come back into our main scene and add a camera. So I'll do that right now. And we'll just do a simple top-down camera. So if I come into our transform here, I'll rotate it -90 degrees in the x direction. This will make sure that the camera is oriented facing straight down, as you can see right there. And we'll just move this up a little bit. So I will say up by 5 units. And now, if I run our game, hit Command B or Control B, you'll see that we have a column of hexagons. This is great. It's working exactly as we expected. It looks like the connection between the faces is at the right amount. The problem is that we don't have any other columns. So that's what we can work on now. First, let's adjust our camera a little bit, just so it's a little bit easier to see what's going on. I'll move it over 3 in the X and 3 in the Z direction, just so that it's a little bit more centered. And if I run this now, we should have a bit better of a view. Again, I'm not going to build any custom camera control just for this tutorial, so you can move your camera around as needed. Okay, so before we actually get to making new columns, let's just very briefly go over the math involved, just so you kind of understand where we're getting the numbers we need from. I'm not going to go totally into this, and you can skip this part if you just want the code, but just wanted to give a bit of an example in case people are curious. So in Godot, when we say that a hexagon has a size, when we say it's got a scale, what Godot's really looking at is this line right here. It's looking at the length from one face to another face. But this length from one face to another face isn't actually the same as from one vertex to another vertex that's across from it. They're slightly different. And in order to figure out what that difference is, all we really need, we don't actually need the actual amount, the actual length of this here, but we do need to find the ratio so that we can multiply it by whatever our size of our hexagon is. So this is the column we just built, right? And if we want to find this value right here, if we want to find the x value to the right to build our next column, we need to figure out what the relationship is between this size and this size right here. And in order to do that, we can take advantage of the fact that hexagons are actually just built of 6 equilateral triangles, which you can see me sketching out right here. I won't keep going with that because my drawing is terrible. But you get the point. And so if we want to figure out the relationship between this side and this, or this line and this line, we can actually just do it by finding the relationship of half of those lines, this and this. And in order to do this relationship, you can see it's a right triangle right here. Oops, that was supposed to be square. We can just find the relationship of the sides of this right triangle. And if you remember much from your basic trigonometry class, you'll remember that if you want to find the relationship between the adjacent side of an angle, which is going to be this, if we're using this 30-degree angle right here, if we want to find the adjacent side of this angle, we can take advantage of the fact that it has a constant relationship with the hypotenuse of that same triangle. And we know that that relationship is that the cosine of 30 degrees of this angle right here determines the ratio between the adjacent and the hypotenuse sides of this triangle. So again, we're not getting all the way in and breaking down what these sides are, but just showing that this cosine of 30 is the value that determines the ratio between these two sides. And not just these two, but by extension, these two here, which is what we want. When we're moving from this point here and trying to find this point, it's this distance and this distance. So we can actually take this knowledge now and apply it to Godot. But before we go back to Godot, remember, not only do we need to know cosine of 30 or sine of 60, you could do the same thing with this angle here, but we'll just use cosine of 30 because we already talked about that. Not only do you need to know the cosine of 30, we also need to make sure we pay attention to how hexagon grids are laid out. You'll notice here that this grid is not this hexagon right here, and then another hexagon that is at the same x value as it. Instead, there's an offset, right? This hexagon is actually moved up this way. So when we're doing our hexagons, we're seeing that our hexagons in the same column, their faces touch each other. But hexagons in another column, they actually have a diagonal face, not a flat face that connects it there. So that's important to know, is our columns are going to be staggered a little bit because hexagons don't connect by touching vertices right here. It's not a connection like this, but rather a connection like we have here. So just remember, we need cosine of 30, and we need to remember how a hexagon grid is laid out. And if you have that, we'll be good to go back to Godot and actually implement this. Okay, so first we'll use the cosine of 30. Remember that we said this is the ratio between the sides. So we know that if we have a tile size of 1, and that this tile size is determining the length of a line between one face to another face, that if we want to find the length of a line that is a diagonal to a diagonal, we need to use the cosine of 30 to get that. And so what we're going to do is say tile coordinates dot x, and remember, we're going to be adjusting our x value here because we are trying to build the column to the right of the previous column we just did. So tile coordinates dot x equals, and here we're going to do x because we want the current column, right? If we're on the 5th column, we need to adjust relative to how many columns have come before. So we'll say x and then times tile size. And this is because if we scale our tiles up, we want to make sure that we space out our columns appropriately. So this will just make it scale proof as our columns or our tiles change size. So we'll say x times tile size. And now the important part, times cosine of degree to radian of 30. And the reason I'm doing this is because the cosine function in Godot and all the other trigonometry functions take radians as their input. But just for the sake of this tutorial, I'm just going to call degrees to radians, which is a function that will convert from, you guessed it, a degree value to a radian value here. And so what this is going to do, like I said, is it's going to build a new column. And remember, this line is only getting run when we build a new column. It's only getting run during the first, or when we move to a new column. It's going to start that column at a relative position based on the scale and column index that we're on, and then move it over the correct amount based on the ratio between our tile size and the line that we're trying to go, the line between two vertices. So we can actually run our game to make sure that this is working correctly. And if we do, we'll see that all of a sudden we've got multiple columns. So this is looking pretty good, except remember how we talked about how hexagon grids need to be laid out. And you'll see that we haven't actually staggered our grid yet. But in order to do that, it's very simple. We're going to add just one more line here, and we're going to say tile coordinates dot y. And the reason for that is because remember, we're staggering in the y direction or in the z direction in our 3D world. And we're going to say tile coordinates dot y is equal to, and here we're going to use a ternary statement. So we're going to just do this all in one line. And we'll say tile coordinates dot y is equal to 0 if, And what we're going to do now is say x modulo, and I'll explain this in a second, x modulo 2 equals 0. And so what we're doing here is we're saying if x modulo 2 equals 0, and if you're not familiar with modulo, it's getting the remainder. Basically what x modulo 2 is doing is saying, is x an even number? So if x is an even number, it won't be staggered. But if x is odd, we'll say else. And here we want to stagger this by half the size of a hexagon. Remember in that grid we just looked at, it's half of our tile size. So we'll say tile size over 2. So if it is an even column, no stagger, but if it's an odd column, we stagger it by our tile size over 2. Now, if I run our game, we will see that we've got a hex grid and it looks exactly like we would hope it would. Okay, so off camera, I created a few extra materials that are just basic flat colors, blue, green, red, yellow, etc., and added a simple function that just keeps track of what index of tile we're on, whether the first, second, third, fourth, or 100th tile, and basically just pulls a material that's appropriate to that. If you want to get this code, you can either copy it right now, it's pretty simple, or it'll be in the GitHub repo for this project, again, in the description below. But the main thing, if I run this now, you'll see that our finished product looks just like this. So again, it's nothing too fancy, but we have a hexagon grid. It's just like they make in Civilization 5 or 6 or any other hexagon-based strategy game, and it's relatively easy to make, and we did it in Godot in 3D. So I hope this tutorial has been helpful for you. If it has, a like and subscribe to support the channel are always appreciated. We'd love to have you in our Discord server. Feel free to ask any questions there. A link to that is in the description below, and would so appreciate if you donated to my channel and buy me a coffee. The link to that is also in the description below. Thanks so much for watching. I'll see you in the next video.